Fluid Coding and AI, Qwen3.6 35B A3B looks like the kind of local coding model developers have been waiting for. Open weights, LM Studio support, long context, vision input, and serious published agentic scores. But this local LM Studio benchmark run tells a more complicated story. The question is not whether the model is interesting. It is whether it is reliable enough to trust as a coding assistant. By the end, you should know where Qwen3.6 35B A3B looks genuinely useful, where the local tests raised red flags, and why a model card benchmark does not automatically translate into a dependable LM Studio coding agent. The short version is this: the model deserves attention, especially for private local workflows, but the evidence does not support treating it as a drop-in replacement for mature cloud coding agents. The headline spec is unusual in a way that matters for local users. Qwen lists the model as 35 billion total parameters, with about 3 billion activated during inference. That is the sparse mixture of experts' trade-off. The model stores a much larger pool of capacity, but routes each token through only part of it. In theory, that gives local users a better speed and capability balance than a dense 35 billion parameter model would. The official model card and LM Studio listing are legitimately attractive. Qwen describes a post-trained causal language model with a vision encoder, Apache 2.0 licensing, long native context and positioning around agentic coding, front-end work, repository-level reasoning, and tool use. LM Studio lists the model with vision input, reasoning support, trained for tool use capability, and a minimum system memory requirement of 21 GB. For a private code assistant, that is a compelling checklist. The published Qwen results are the reason people are paying attention. The model card reports 73.4 on SWE Bench Verified, 80.4 on Live Code Bench version 6, 51.5 on Terminal, Bench 2.0 plus strong GPQA and MMLU, Pro numbers. But those are Qwen's published model card results. The notes matter. They involve specific scaffolds, temperatures, context windows, multi-run settings, and evaluation choices. They are useful evidence, not a guarantee for your local setup. Now the reality check. In the first-party LM Studio benchmark report, the model scored 706 out of 1,578 across all benchmark suites. That is 74% overall. That number should not be overread. The coding category has a much larger point scale than the 1-point non-coding cases, so the total percentage is dominated by coding. But as a local workflow signal, it is hard to ignore. The local run was not simply bad. It passed every quantitative reasoning case and every data interpretation case. That includes easy, medium, hard, and very hard cases in those two categories. So the honest read is not, this model cannot reason. In this suite, it handled structured numbers and data interpretation cleanly. The weakness appeared when the task shifted toward practical coding, source research, safety edge cases, and exact writing edits. The coding results are the uncomfortable part. Out of 21 coding cases, only one easy coding task was a clean pass, the date range validator. The other easy coding tasks mostly failed with partial credit. Every medium coding task failed. Hard and very hard coding included multiple timeouts, including job queue, notes permissions, billing ledger, policy authorization, and workflow orchestration cases. That is exactly the zone where people want coding assistants to be dependable. The official benchmark story and the local benchmark story can both be true. SWE bench-style results depend heavily on the agent scaffold, context handling, retries, tool environment, and evaluation harness. The local report also does not include hardware, quantization level, LM Studio version, backend, sampling settings, context size, or whether thinking and tool use options were enabled. A different quant, runtime, or harness could change the result. So this run is evidence for this setup and this suite, not a universal verdict on every Qwen3.6 deployment. Tool use is another place where expectations get inflated. LM Studio's docs make the division clear. The model emits a tool request, your code executes the tool, and the result is fed back into the conversation. That means agent reliability is not just, is the model smart? It is model formatting, parser behavior, chat template support, tool schemas, local runtime speed, and your orchestration code. If any one layer is brittle, the assistant can fail in ways that look like bad reasoning. The strongest practical argument for this setup is privacy. LM Studio can run models offline after the files are downloaded, and local server requests stay on the device. For teams that cannot send private repositories, customer examples, or internal prompts to a cloud API, that matters. Even if the assistant is less reliable than a frontier cloud workflow, a local model that can safely handle sensitive context can still be useful for review, exploration, and smaller coding tasks. If you try Qwen3.6 35B A3B locally, test it like engineering infrastructure, not like a vibe check. Start with 5 real tasks from your own workflow: 1 small bug fix, 1 API change, 1 refactor, 1 source research task, and 1 tool calling task. Track pass, partial pass, fail, timeout, and manual rescue time. Then compare quantization, context length, backend, and agent settings. The useful question is not, is the model good? The useful question is, where is it reliable enough for my work? My verdict is cautious interest. Qwen3.6 35B A3B is worth testing if you want an open-weight, private, LM Studio-friendly assistant with strong published model card signals. But this local benchmark does not support blind trust. In this run, structured data and quantitative reasoning were excellent, while practical coding completion was weak and harder agentic cases often timed out. Use it as a local assistant candidate, not as a proven autonomous coding agent. If this helped you separate model card promise from local coding assistant reality, like the video and subscribe to Fluid Coding and AI. I will keep testing local models the same way, with receipts, caveats, and practical developer workflows.